Hey, Natasha, what are you doing?
Hey Claire, so I am building a pipe cleaner tower to prepare for my STEM class next week.
Why do you need a pipe cleaner tower for your STEM class?
So this is one of my favorite icebreaker activities. So I have groups of students get in teams to try to build the tallest freestanding tower using pipe cleaners. And since we're doing distance learning, they're going to be doing it individually at home, but I love doing this one in the classroom. What are you doing next week?
Well, in my STEM class, we're programming robots. So, my,
Fancy.
so I'm wondering if you're building towers out of pipe cleaners, I'm programming robots. Are they both STEM? Like, are you teaching science, technology, engineering, or math?
That's a great question. And it's actually the topic of our keynote presentation for STEM for Innovation, which starts right now. We should probably get to it. You ready?
Ready.
Let's go.
Hey, I'm Claire Meshkat.
And I am Natasha Wilkerson, and we are really excited to be here for the STEM for Innovation conference, which is sadly virtual, but we're excited to be able to connect with all of you in Aggieland or across the country.
That's right. And to give us a little bit of background about who we are, I am a STEM coordinator and kindergarten through 7th grade STEM teacher at Open Door School in North Texas.
And I am the STEM director with Communities and Schools of San Antonio. And I'm actually also a Texas A&M student, a graduate student in science education in the Teaching, Learning, and Culture department. And back in 2014, Claire and I co-founded Vivify, which is a STEM resource company. And so we're excited to talk with you guys today.
That's right. So our story actually started here at Texas A&M, where we were both classmates, and we love to do extracurricular stuff that A&M had to offer, like Aggie Replant, if some of you guys are Aggies as well. We did outreach opportunities where we would go to elementary schools and teach them what we were learning in the classroom. So interestingly enough, we are not originally educators. We both graduated with degrees in aerospace engineering. And so you'll see some of our coursework included learning about aircraft. That's Natasha and I sitting in an airplane during one of our courses in aerospace. We were teaching the kids on those pictures on the right, we were teaching them how to build rockets. And then we did our senior design project at A&M building rockets on the same rocketry team, which is in that center picture.
And so after our fun years in Aggieland, we went our separate ways and worked as engineers. So I went up to Maryland and worked for the Department of Defense as something called a spectrum engineer. And basically everything like radars and satellites that needs to communicate operates on a specific frequency. Just like if you're turning the dial on your FM radio, you have different stations, the same thing for satellites. And so one of my favorite projects was getting to work on this satellite called SpinSat that ended up going to the International Space Station. And I was part of the team that made sure it was operating on a frequency that got the scientific data it needed. It did not distort any of the other channels. So that's a little bit of what I did as an engineer.
And then I went straight to work for Boeing. I first worked at Boeing Commercial Airlines. So you can see a jumbo jet in the background of that first picture that I got to work on, the Dreamliner 787. And then I went and worked for Boeing Space Exploration on the Space Shuttle program. So there's a picture of me with an actual astronaut suit. And then I went and worked for a company called Air Tractor, which builds firefighting and agricultural aircraft, which you may recognize the iconic Dusty Crop Hopper from Disney Planes, which was modeled after some of the aircraft that I helped design.
And from there, we kind of discovered our passion for education, both separately. I was starting to volunteer as I was working as an engineer with some kids up in DC and just fell in love with working with students. And when we moved back to Texas, I jumped ship from engineering and joined Communities and Schools in San Antonio, Texas, and started this Space Club program.
Yeah, So it took us a while to, I think, realize that our true passion was teaching kids. And so I also, in my spare time, was teaching kids at local elementary schools. I taught STEM for a homeschool co-op, and then finally made it to where I did what I was passionate about for my day job, and started teaching in the classroom at a school. And I love sharing what I learned as an actual engineer and teaching kids about rocketry and environmental science, and especially robotics. You'll see that picture with a Sphero robot, which, quick plug, I will have a session later in this conference teaching you how to do STEM activities with Sphero robotics.
And so a little story, I mentioned starting this Space Club program. It wasn't really that easy to get started. I remember begging principals in these schools, these are Title I schools, high poverty, they didn't have these type of programs. And so the principals were very skeptical that kids would actually show up to a STEM program. And I was like, just give me a chance. I bet you they'll come. I wasn't exactly sure if they would. I was just hoping that I could inspire them to attend. And so I remember one school took a chance and let me come into their science classroom. And so I brought some of those rockets that Claire showed, those model rockets. I had a quadcopter, took it into the science classroom, and I was just showed the kids. I was like, hey, this is the kind of stuff we're gonna do in this after school program called Space Club. If you're interested, please join me. And I'll never forget that first day. They had put us in the very back of the school in this portable, and there was all this commotion going on. These kids were running around, and I was like, what is going on? Are they selling hot Cheetos? It was a San Antonio thing. Like, why are these kids here? And when the teachers said, they're here for Space Club. And I was like, no way. Because we had kids, I saw them carrying their band instruments, some were wearing their football jerseys, and all these kids are here to listen to me talk about engineering and apparently do some cool hands-on projects. And it's just kind of been since then this wild ride where we've, launched weather balloons and rockets. And this is one of my favorite pictures. The first year I decided to take 200 kids to NASA, Johnson Space Center in Houston. This was the first time that these kids have left their neighborhood, let alone the city. We took them to Houston. It was amazing. One of the students here, I remember her telling me she was cleaning houses with her mom to save up money just to buy a souvenir at NASA. Like, that's how important this trip was to her. And so I'm very passionate about this program, and we just love being educators.
That's right. I mean, sharing what we did as engineers and that excitement that it gives kids, it motivates them and gives them some inspiration. But we haven't answered the question about what you're doing with those pipe cleaners, and is that really STEM? So maybe we should back up a little bit and define what is engineering.
That's right. And whenever I go into a school, especially if this is the first time they've ever done anything with STEM, I'm usually the first person they have ever met who's an engineer. So they have absolutely no idea what engineering is. And I like you said, this is the perfect place to start. So what I do is I tell a story. Are you ready for story time, Claire?
I'm interested.
Okay, so this is what I tell the students. I say, in 1900, New York City had an unimaginable pollution problem. What do you think that problem was? Any guesses?
Rats?
Probably. There probably were a lot of rats. So one of the problems they had was poop. Lots and lots of horse poop in particular. And how much? Well, there were 4 million pounds of poop lining the streets. 60,000 gallons of pee. You did not see this coming, did you? 3 billion flies buzzing around, and unfortunately that was spreading disease. And so they're estimating 20,000 people were dying from diseases related to all this horse poop everywhere. And the crazy thing, I was reading that experts back then, this was in the newspapers, they predicted by 1930, New York City would be buried in 25 feet of poop, 2.5 stories of poop. I mean, like, that's just unimaginable, right?
Yeah, I'd say that's a pretty big problem.
Yeah, slightly. And of course, this did not happen. And maybe you guessed why we do not have poop lining the streets. And that's because of the invention of the automobile. And this was a much faster, efficient way to travel. So we got rid of the horses and we moved to the cars. And of course, that comes with its own set of pollution problems. But the moral of the story is that engineers are designing a future that often we can never imagine. And I love to tell students that we do this as engineers by using math and science, problem solving, and creativity to design this future. And here's some images that I found of what maybe a potential future city designed by engineers could look like. And there's a great resource put out by the American Society of Engineering Education. It's a digital magazine, and it has all these really cool technologies that are futuristic by engineers. So I recommend you check that out.
And the amazing thing is engineers solve problems, but there's such a wide variety of different types of engineers that can make our lives easier, healthier, and happier. So we like to share with our students that there is a variety of different things that if they're interested in, they could find something that engineers do that relates to that. So for example, biomedical engineers will build nanobots to go in and maybe even cure cancer to target those cells. Or maybe they want to be a robotics engineer and be able to build robots that can go rescue people where humans cannot. Or maybe they wanted to do something like what I did and become an aerospace engineer and design crop dusters that help feed the growing world population.
So that was what is engineering, but the next question is who is an engineer? And there's a lot of stereotypes out there of what an engineer looks like. And so we're gonna play a little game here and have you guess if you think this person, we're gonna show you a picture of somebody, if they're an engineer. So I'm gonna do this first one. So is this person an engineer? And you can imagine doing this with your students and trying to get their reactions on, is this an engineer? And this is actually Jeff Bezos. You probably know who this is, Amazon CEO, and maybe you didn't know, he is actually an electrical engineer.
Pretty awesome. So next one, is this gal an engineer? And this, of course, is Emily Calandrelli. She's an aerospace and mechanical engineer. A lot of kids may actually recognize her because she now has a TV show called Emily's Wonder Lab where she gets to do lots of engineering and science experiments with kids. It's pretty awesome.
I love her. Okay, is this person an engineer? And it's actually a trick question. So Simon is the actor, and he is not an engineer. He, of course, plays an engineer on The Big Bang Theory, but this show really promotes a lot of stereotypes that kids have, and that's all over movies, television. If you just search engineer, you get some of these stereotypes that I try to steer my kids away from, just so maybe they can picture themselves as an engineer.
So lastly, what about this girl? Is she an engineer? Yes, this is an electrical engineering graduate student.
And so the purpose of this game is all these people are engineers. And I then asked the question, how did you know if they were an engineer? And you should not be able to tell by how someone looks if they're an engineer or a scientist or a mathematician. And of course, the message is anybody can be an engineer. All right, what is STEM? Now we're getting closer to that question we asked in the beginning. How is that pipe cleaner tower STEM? So let's talk about first, what is STEM? You are in the STEM for Innovation conference, so I sure hope you know this acronym, but we got science, we got technology, we have engineering, and we have math. And the way I like to bring this all together is students in a STEM program are applying math and science to solve an engineering problem using technology. And here's some examples of what that could look like.
So you'll see a snapshot of what my STEM classroom looks like here. You'll see a helium stick challenge, which is something I use as an icebreaker to work on teamwork. And you'll see Lego building. That's where we do a lot of prototype building with Legos. We program bee-bots. We build cup towers without touching it, using just strings and rubber bands. We do engineering design challenges like this lander challenge that you'll see down at the bottom, and even launch high altitude balloons to the edge of space. So that is a wide variety of activities, but are all these things actually STEM?
And that's something that I remember when I started, I really struggled with, because if you just Google STEM activities on Pinterest, you're going to get this full range of activities. And honestly, not all of them are the same. There's no way a pipe cleaner tower is the same as what you're doing, which is programming robots, or if you're doing the first Lego League. But I want you to kind of rethink the way you approach STEM. And you can think of it as these different stages that build up on each other to prepare students for those more advanced projects. So I do a pipe cleaner tower challenge in my classroom because it's where I need to start. My kids can't start in a robotics competition and succeed. There's a lot of skills they need from those early on STEM challenges. And pictured here, these are some of our Space Club kids. We start the year with a pipe cleaner challenge, and then we end by designing a colony on the moon. And so let's dive a little bit into what each of those stages looks like.
So stage one STEM, that's what we briefly touched on, like the pipe cleaner tower challenge, really focuses in on those 21st century skills. That's collaboration, teamwork, communication, working on problem solving where you persevere through a challenge. And an example of this that you most commonly see is tower building challenges. So building a tower out of pipe cleaners, or maybe even with these tiny little chairs that I found on Amazon, or with plastic cups. And you don't have to just do these challenges to build teams in classroom settings. You can even do this during distance learning. So if you need more examples of what that really looks like and how to facilitate that team building exercises, you can look at these icebreaker ideas in this bit link that we are showing on the bottom, how to do them in the classroom as well as in distance learning. So after you've practiced those teamwork skills and your 21st century skills, you're ready for some stage 2 STEM. And we see this as kind of the heart of what a STEM program has. It's where you really are able to learn the engineering design process and apply math and science concepts to those design challenges. So some examples of those are the drag device challenge, which is basically building having a payload being dropped from a certain height using a parachute. So those first two pictures show my students doing some of those challenges. You're able to incorporate some science concepts like gravity, aerodynamics, you're obviously talking about drag, and then bring in some math as well in being able to calculate the velocity of your payload as it hits the ground with and without your parachute. Maybe you also want to work on building catapults with your students. This is a great challenge using the engineering design process. You can incorporate the science concepts of elastic potential energy as they launch their projectile either the furthest distance or to enhance their power in knocking over a tower of cups. You can calculate the angle that you're using to launch it, as well as work on accuracy and precision.
And often this is where STEM programs usually go. They end in these engineering design challenges that you just keep repeating every week or every month. You have a new design challenge. And so I want to push teachers here that you can go beyond this. And that's stage 3, which I teased a little bit with that Mars colony competition. These are projects that take more time and they mimic what a real world engineering challenge looks like. So they're more open-ended. You're still applying the math and science concepts, engineering design challenge, but there's a research element and it's multidisciplinary. And so for example, in my lunar colony competition, they're needing to do some architecture. So thinking about scale models. They're learning about the history of space exploration. They're learning about different technologies from hydroponics to solar panels. And then they're also connecting mental health. So in this colony, how are you gonna be happy living with these same people day after day? What is the bedroom gonna look like? How are you gonna deal with homesickness? And so I love these projects, and this is where I really find that STEM can be inspiring for kids and really build their skills to become an engineer or scientist someday. And something I wanted to talk about is distance learning. So we're all dealing with this pandemic and we're having to switch how we traditionally do STEM into a virtual environment or through social distancing. I struggled with this in the summer. I was trying to do these same STEM activities and it just wasn't working. The kids were not logging on, they were just checked out. And I really was like, how do I get these kids to want to do STEM? It's so much fun when I have them in person and they're forced to do it, right? And then they get excited and they keep coming back. But as all of these educators watching, like, you know, it's been a struggle. And so we changed it up a little back in October. We introduced this new idea of gamifying our STEM program. So through Space Club, we call it Mission to the Moon. And basically, students still work in teams, but virtually, and they get points for every engineering challenge. And I want to show you some of the results of that. So these are all projects done at home. You can see this like robot hand, and this is all recycled materials. They've even been planting some seeds here and growing them. They designed still that same lunar colony at home on their own with some guidance virtually through educators. And I'm going to dive more into how I did this and the different tools that I used. If you're interested in doing a similar program or just finding out how can I improve my own STEM classroom if you're doing it virtually, I am running a session on that, so join me. But if you want to know more about this Space Club program, there's a bit link down here. Okay. So now we've kind of talked about those different stages, how not all STEM is equal, but I think it's important to just reflect on why STEM? What's the purpose of STEM? Now that we know how to build a STEM program, the question is why? Why would someone want to bring STEM to their school? And what do you think?
That's a great question. And I think our whys might be the same, is that we have lived what the end result is of STEM education. It's to fill these jobs that are so needed and will always be needed as engineers, scientists, technologists. And so to be able to share those with kids and inspire them to be problem solvers as well, as we equip them with the skills that they're needed, it's just incredible what it can do for them, not only academically, but for their entire future. So has that been your experience as well?
Exactly. Whenever I introduce myself, I might have had a few people wonder, why is someone with an engineering background at a nonprofit, right? Communities and Schools of San Antonio, its core mission is to work with at-risk kids. And our job is to keep kids in school and to succeed in life. And usually we're talking about counseling and food packs and transportation. But I have found that STEM fits because it inspires kids to want to stay in school, to understand, hey, I could someday be an engineer and scientist. That's why I need to take these math and science classes. And I have this perfect story that comes to mind. It was my second year as a Space Club instructor. And there was this girl that I'll never forget. And she would show up every day with the most positive attitude. She was obsessed with Space Club, the first one in, throw her backpack, ready to go, whatever it is we were doing. And we got to the second semester. And that's usually when I lose a lot of students because they have other interests, sports and band, but she was dedicated. And so we started our colony competition. So that year's theme was Mars. And so their task was to design a colony on Mars. And unfortunately, a lot of her teammates had left. They had other things they wanted to do, and it was her and this other student that were left to build this whole project. I would later also find out that she was suffering from bullying in class, in other classes. I had no idea about this. She was the most positive student, dedicated. I would have never thought that. But Space Club was the reason why she was going to school, because she loved it so much. Unfortunately, like I said, her team abandoned her, and it was the week before the competition, and they had nothing. They kept fighting, they were tearing it apart, and she was like, I'm gonna finish this. And she was the only student I let take her project home. Honestly, did not have a lot of expectations, because a 7th grade student trying to finish a project, this was months of preparation, right? And she was gonna try to do it in a week. Okay, the day before the competition, her mom drops it off at school, and it was just mind-blowing. She had taken like toothpicks and popsicle sticks and built like this intricate model kitchens and beds. She had this hydroponic system. She had built solar panels to represent what her colony would look like on Mars. And I just like thinking about it just gives me like goosebumps because it was just so amazing. And then that day, the competition, nobody knew the story, right? All they know is they're going around these judges. We have architects, we have engineers, we have scientists, and they're asking these kids, You know, why did you build that? Why did you pick that power system? How did you design your scale model? And her team, it was just her and that other girl, the two of them ended up winning Best Architectural Design, awarded by these architects.
Wow.
And everybody else had like 8 people on their team, and it was just the two of them. And her mom, when I announced the award, I hear her screaming in the background, and the girl's face just like dropped and was like, me, like I won that. And this part, you know, we talked about the story. So a couple of days ago, I had a coworker that texted me, and right now they're announcing everybody who is getting college acceptance. So she's now a senior in high school. And so I got a text a couple of days ago, and she just got accepted to University of Texas, which I know is the other school, but she's going to study engineering. And I mean, just because of that one moment of Space Club, she persevered through everything she was going through, ended up going to STEM Early College High School, and now is going to be an engineer. And that's why we do what we do.
That's exactly right. Man, that's amazing. What a difference we all can make if we just give just one student that opportunity.